Kubernetes is a lot of things, so I want to definitely break down some of the basic topology and parts of the system before we get into installing an app on Kubernetes. First up is Kubernetes itself. That is essentially when I'm talking about the entire system, either a single server or multi-server setup with all the parts together that are there to run your apps. And we abbreviate that sometimes as K8s. So normally when I'm talking about Kubernetes, I will just say Kubernetes, but often in writing or even in the documentation, you'll see the K8s, and that essentially is a short abbreviated version of Kubernetes. If you actually look at it, the 8 means the 8 letters between the K and the S, and that's why they did. So the K, 8 letters, and then S, that's their abbreviation. Sometimes people might call it Kube, but essentially here we're going to be talking about the same thing when we say Kubernetes and K8s. Now, kube control is the command line tool that you will use to talk to the Kubernetes API. The main way we talk to Kubernetes is through its API, and there's multiple tools out there that can do it. In fact, there's lots of tools that can talk to the API, but the one that really comes officially from the project and that we'll be using most of the time is kube control. Now, you may see this being referred to in other videos or talks as kubectl or kubectl or kube control, all sorts of other types, or maybe even kubectl, but those all are the same thing. They're essentially different people saying it a different way. In fact, just about a year ago or so, they decided to officially call this tool kube control in the documentation, but there really is no wrong way to say it. Now, just like with Swarm, where we call nodes the servers that are inside of that cluster, Kubernetes also refers to things as nodes as well. So that terminology is at least the same between the two. And kubelet is the container that will run a small little agent on each node to allow that node to talk back to the Kubernetes master. Now remember, since Docker had Swarm built in, it didn't really need this separate agent. That was all built into the Docker engine. But now with Kubernetes running on top of that, it needs its own engine API that talks to the local Docker or the local runtime, whichever that may be, and then it talks back up to the control plane or master, which is in charge of running the Kubernetes cluster. Now, the control plane, sometimes called the master, is what's in charge of the cluster. And if you're familiar with Swarm, in Swarm we had the manager. There could be one or more managers. We wanted an odd number of managers. And then there was workers that were doing all the work. And if you remember from Swarm, the managers could also be workers because they could also run containers themselves. And so you could technically just have a single server. You could have many servers and have the two roles split out. A lot of that is very similar in Kubernetes. We just have slightly different names for it. So the control plane, also something we ran in Swarm, is the part where the servers are running all of the stuff that's in charge, essentially. And it's more than one container. It's a group of containers, and they run individual things. So they take the Linux principle of do one thing and do it well, and they take that and split everything up. So essentially, each one of these parts is doing one thing and doing it well, and it simplifies the design in terms of the development. But when you have to build this and run it, it does make things a little harder to set up because there's more to it. And this control plane includes containers that will be running the API, the scheduler. You actually need a database backend that will be something called etcd. And then you have controller manager. You probably need something called core DNS to handle your DNS and so on. So we have a lot of parts here, but let's put it on a diagram and see if this helps make sense. And I'll compare it to Swarm since you've already learned that in this course. Now, if you only had one machine, like we're going to do in a minute for learning, all of the things I referred to previously would all be in the same server. So they would be a bunch of running containers, and that's what you'll see on things like Minikube and Docker Desktop when you're running a single node Kubernetes. But in the real world, when you get on servers, you're going to break this stuff out. So I thought I would show you really quick on a network diagram how this might look and explain the different parts. First, let's assume you have a master. Now, in a multi-master setup, you would have 3 of those. Just like with Swarm, you need odd numbers because it uses the same raft protocol to keep consensus just like Swarm did. Now, in the documentation, these are all known as master, but it gets a little confusing when you have more than one master because it's the same setup where you can only have one that's really doing the job of writing the etcd. So these are also known as the control plane. And you'll recognize that term from Swarm, which was referring specifically in Swarm to the protocols over the network that were allowing the masters and the nodes to all talk securely for giving orders. But here, it's a little bit different. The control plane is talking about the master nodes that are all making decisions. And just like with Swarm, we have worker nodes. In the documentation, they'll really just be referred to as nodes, but sometimes you see the word worker mentioned. So we're going to call those nodes here just to be consistent. Now, again, like before, all of these can run containers, but generally you're going to keep your apps to the nodes and the Kubernetes management systems to the masters. Now, all of these are running on top of Docker or some other container runtime like Containerd or CRI-O. And inside of each master, we're going to need to run multiple containers to keep control of the system. And the first of that is etcd. etcd is a distributed storage system for key values. So it's very similar to how Swarm works with its wrapped algorithm system. And it's similar to etcd, but etcd is a separate product and is something you can install without Kubernetes just to store configuration data. And it uses the same Raft protocol, so a lot of the same rules apply. You need odd numbers. You can start with 1, but if you want true fault tolerance, you need 3, and so on. On top of that, you'll need to run multiple Kubernetes containers that will store data inside etcd and manage the cluster. First up is the API, which will be the way we talk to this cluster and issue orders to it. Next up is the scheduler container, which will control how and where your containers are placed on the nodes in objects called pods. Next up is the controller manager, which looks at the state of the whole cluster and everything that's running in it, and it uses the API to do that, and it takes the orders that are giving it, or the specs, and determines the difference between what you're asking it to do and what's actually going on. It's basically a loop that's differencing the whole system and figuring out how to make everything that's currently happening the same as what you've asked it to do. And then you'll need something to control DNS, which isn't built in, and by default, that's core DNS. And depending on other add-ons that you get later, like networking or storage, web, and other features, you'll have more containers running here as well. Now, on all the nodes, they're going to need an agent running, and that's known as kubelet. And to start with, you'll need kubeproxy to control the networking. And just like with Docker, all of these will be repeated for their roles. So the masters, if you were going to do multi-master, would have all those same containers set up. And each node that you set for worker nodes will also have those at least 2 containers there for management. And Kubernetes is designed to solve lots of problems in lots of ways. So you'll find yourself possibly adding more things to masters, more things to nodes, such as networking. On the master side, there's lots of other optional tools to add on to it as well. But let's get to installing this on your local system for learning. For Kubernetes, it's a series of different containers. We've talked about that. And on top of that, you have a command line tool that's not necessarily bundled with those containers that run on the server. So you've got some more parts than Docker would normally have, and there's different ways to set this up. And in fact, there's tons and tons of ways to install Docker. There's lots of distribution, there's lots of installer tools. Each way will be slightly different and package different containers. Now, largely, there's going to be the same 4 or 5 containers that you have to deal with. And we're really focused just on learning right now. So I want to get you the local setup, the easiest way for you to use. And there's certain other things that I look at too for the best way to install is what is RAM utilization and is it easy to turn off? Because these are things where you've got a lot of containers running in the background. You may not want those to always be running. And how is it easy? Is it easy to reset it? Is it easy to use with my local system? And rather than just always having to refer to some foreign endpoint somewhere else. So With Docker Desktop, if you have Docker Desktop, that's the best way to go. That's the easiest install of all Kubernetes. As if you have Docker Desktop, just use that. If you have Docker Toolbox, then you're probably going to want to use Minikube, which is very similar to the Docker Machine command line, which is what makes Docker Toolbox work. And we'll talk about that in a minute. And if you're someone who's got Linux on your desktop, or you just want to do this natively in a Linux VM you've already created, either on your machine or on the internet, then the easiest way there to probably set it up for learning purposes is Micro K8s. It's made by Ubuntu, but you can install it on a lot of different distributions. It's not specific to just Ubuntu. And if you're just not at a place where you can install Kubernetes, or you don't want to create a cloud VM or whatever, and you just want to learn it in a browser, that's fine too. There's two good options. One of them is Play with K8s, which is made by the same group as Play with Docker. And then there's Katacoda. And Katacoda is very similar. In fact, if you looked at both of these tools, they look like they do the same thing. The slight difference there is that the Play with K8s requires that you actually install the cluster and set it up, and Katacoda already provides the setup for you. So it's, I think, a better tool to learn with because it doesn't require you to worry about installation, which you might just wait later to learn how to do that, and you just focus on how it works, what the command lines look like, and stuff like that. So if you had to choose between one or the other, look at the resources of this lecture for the link to the Katacoda playground. For me, I would prefer Docker Desktop because it provides me several things out of the box. One, it's a checkbox to install Kubernetes on my existing Docker setup. So whatever the Linux VM is on Mac or Windows, it's going to automatically add the Kubernetes setup to that. Then it's also going to install the kube control command line on my local machine, whether it's Mac or Windows, and make sure that version is the right version to match to the server. In fact, if you're using Docker Desktop Enterprise, which is a new paid offering from Docker, they actually allow you to swap between different versions of Kubernetes on the fly in case you're maybe in an enterprise environment that is specific to different clusters running different versions, and you want to test different versions locally very easily. But most of us won't need to do that, so the free version of Docker Desktop works just fine, like you've used in the rest of this course. And the other nice little thing there is that Kubernetes uses up a decent amount of resources on your machine. Now, Docker's already using resources, so it's sometimes a little tight to also run Kubernetes on top of that and then get the rest of your work done. So Docker Desktop provides a quick little checkbox in the menus to allow you to disable the Kubernetes part of the cluster while still leaving Docker running. And that's a neat option because sometimes I just want Docker and I don't need Kubernetes. All right, next up, if you're a Docker Toolbox person, Minikube is the closest replacement to that. Now, it doesn't even need Docker Toolbox to be installed, so you could totally just run this separately. But it's very similar in the way that Docker Toolbox works. So I think for those of you using Toolbox, this will be a similar experience. You would download the installer on Windows for the Minikube binary, and it would install that. Now, you could just download the binary directly from GitHub, or you could just download the installer. I kind of like the installer just because that's the Windows way of installing things. You can also get it off Chocolatey if you're into that. But regardless of which method you get it downloaded, it's a single binary. And once you get it there, you just type Minikube start. Now that assumes you have VirtualBox installed, which if you have Docker Toolbox, VirtualBox would have been installed already. So the nice thing is this uses that same virtualization backend by default. The other thing is that the commands of it are very similar to Docker Machine as well. So you start, you can remove a machine, you can reboot the machine, you can do all those typical things like you could with Docker Toolbox. But the one gap here is that it doesn't install the Kubernetes command line that you would most often use, kube control, which is what we're going to use throughout the rest of this section. And so you're going to have to go and install that separately, which is just its own single binary. There's multiple ways to install it. And in fact, when the Minikube is finished setting up, it will give you a URL that you can go find the instructions on how to do that. All of this really shouldn't take you very long. All in all, it's really just VirtualBox and a couple of executables on your machine, and away you'll go. You'll have the VM running. It'll have kube control on your Windows machine that talks to that VM, and then you're ready to start. And for those of you that are on Linux as your host OS, or you just installed your own Linux VM, or maybe using a Linux VM in the cloud, the easiest way I think to get Kubernetes running on that machine is to use Micro K8s, which is from Canonical, the company that makes Ubuntu, but it works on any Linux distribution, I think. I checked the list and it was pretty comprehensive. It installs using Snap. And if you're not familiar with Snap, it's a different type of installation technology,
but does the same thing as apt-get or yum. You just have to get snap installed first. If you don't already have it, you can just type snap, and if it says it can't find the program, then you know you don't have snap installed. And you can probably find snap in apt-get or yum. Then once you have that, you would use a snap command to install the micro K8s. Once you've done that, it will do everything else for you. It will install all the different master roles. It'll automatically install the correct version of kube control. And it gives you a nice set of commands to manage the Kubernetes system with micro K8s dot something. So you can do micro K8s dot enable and other different commands. If you just type micro K8s dot and hit your tab key a couple times, you'll see it lists out all the various options. And so it's easy to manage that, even uninstall it pretty quickly if you don't want Kubernetes anymore. The one quirk with this one is it doesn't give you the default kube control out of the box. And I think that's to keep it from conflicting with maybe if you have kube control already installed. It gives you a new command that is the micro K8s dot kube control. Now, what I recommend is if you're using bash or ZSH is to go in to your profile that automatically runs every time you log in and simply add an alias so that you can type kube control and it will control this cluster. Because as we go through the examples with that command line, I don't want you to keep forgetting that, oh yeah, on my machine, I have to type micro K8s dot kube control, right? So you definitely want to make that alias. I always do that. And a little tip there is I actually just make my alias the letter K. So I don't even have to type kube control. I can just type K and then something else, right? So you could do that as well instead of the full word kube control. But that's maybe something you do later once you've got all this stuff down. The advantage of you learning Docker, then Compose, and then Swarm is that you have so much of the basic knowledge here that I don't have to start from scratch with I'm teaching you Kubernetes. But some of the terminologies, especially when we talk about the objects inside of Kubernetes that you control and use, the terms can be a little bit confusing because some are conflicting and some are just new. By far, the number one thing you're going to keep hearing if you've ever looked up anything in Kubernetes land is the pod. And the pod is the basic unit of deployment. We don't technically deploy containers directly inside of Kubernetes. We only deploy pods, and we use things on top of that known as controllers to control those pods. Technically, you can deploy a pod directly, but you're not really going to want to do that. Almost always, you'll create a controller that is an object that continually sits there and validates whether or not what's going on inside of Kubernetes is what you've asked it to do. It's a differencing engine that has different types, and you start out with deployments and replica sets, which you'll be using almost exclusively. Deployments are very similar to the way we did services in Swarm, and that controls your pods at lower levels. Then you can change up and do different types of controllers, even third-party types of controllers, including stateful sets and daemon sets and jobs and cron jobs and so much more. So that's part of the flexibility of Kubernetes, is that it gives us this basic unit of pods and then allows us to control that with controllers in different ways, and it allows us to get really creative with how we deploy our systems. Now, the service is a little bit different in Kubernetes than you were used to in Swarm. The service really doesn't have anything to do with deploying applications like you would in Swarm. The service is specifically the endpoint that you give to a set of pods. Often when you use a controller like a deployment controller to deploy out a set of replica pods, you would then set a service on that. And the service just means you're giving it a persistent endpoint in the cluster so that everything else can access that set of pods at a specific DNS name and port. Next up real quick is a namespace. We won't really use namespaces much in Docker Mastery itself because it's an optional advanced feature, but you will hear it mentioned if you're looking in documentation or reading blogs and whatnot. The namespace is really just a filter on your view at the command line. That's really all it is. It's not a security feature. If you're familiar with some of the internals of Docker, you hear about namespaces in Docker. This is in no way the same thing. This is simply a way for you to filter your views when you're using the kube control command line so that you only see the things you care about at the moment. A good example might be when you're using Docker Desktop, it defaults to the default namespace and filters out all of the system containers running Kubernetes in the background, because normally you don't want to see those when you're running the kube control command lines And then you can change the namespace to see those if you want to see the different views. And so just think of it as a filter, not a security feature. And of course, there's so much more to Kubernetes that we'll get into eventually. There's secrets, there's config maps, there's a bunch of third-party stuff. But enough with the concepts. Let's type some commands and see results at the command line, and then we're going to visualize it on the drawing board.